Question 1a. Simplify n cubed times n to the power of 5. When we are multiplying, we add the powers. So this is equal to n to the power of 3 plus 5 equals n to the power of 8. Part B. Simplify c cubed times d to the power of 4 over c squared times d. We can start by cancelling out c squared. Dividing by c squared means that we are subtracting the powers. This results in c. Then cancel out a d. D to the power of 4 divided by d is d to the power of 3. So the final answer is c times d cubed. Part C. So 5x over 2 larger than 7. Start by multiplying both sides by 2. This cancels out a fraction. This results in 5x larger than 14. Then divide both sides by 5. So the final answer is x larger than 2.8. Question 2. Andy cycles a distance of 30 kilometers at an average speed of 24 kilometers per hour. He then runs a distance of 12 kilometers at an average speed of 8 kilometers per hour. Work out the total time Andy takes. Give your answer in hours and minutes. The distance d for the first part of the journey is 30 kilometers. The speed is 24 kilometers per hour, and we need to work out the total time it takes. The distance for the second part of the journey is 12 kilometers, and the average speed, s, for the second part is 8 kilometers per hour, and we need to work out the time for this part as well. The formula for the speed is distance over time. Rearranging this, we got the formula for the time. The time is distance over speed. The time for the first part of the journey is 30 over 24. And this is 1.25. The time for the second part of the journey is 12 over 8, and this is equal to 1.5. The total time is 1.25 plus 1.5, and this is 2.75. The 2 in front of the decimal point represents the 2 whole hours it took. And we also have 0.75 hours. Multiplying this by 60 minutes gives us 45 minutes. The total time it takes is 2 hours and 45 minutes. Question 3. A number m is rounded to 1 decimal place. The result is 9.4. Complete the error interval for m. The lower bound is 9.35. The upper bound is 9.45. Question 4. Maisie knows that she needs 3 kilograms of grass seed to make a rectangular lawn 5 meters by 9 meters. Grass seed is sold in 2 kilogram boxes. Maisie wants to make a rectangular lawn 10 meters by 14 meters. She has 5 boxes of grass seed. Has Maisie got enough grass seed to make a lawn 10 meters by 14 meters? You must show all your working. We know that a 5 meter by a 9 meter rectangle will need 3 kilograms of grass seed. And we need to find out how many kilograms does a 10 meter by 14 meter rectangle will need. The area of the first rectangle is 45 meters squared. The area of the second rectangle is 140 meters squared. Writing this out as a ratio, kilogram to area, 3 kilograms fills up a 45 meters squared area. Let's use x for the unknown. This represents 140 meters squared. Using a quick cross multiplication method, x is equal to 3 times 140 over 45 equals 9 1/3 or 9.3 recurring kilograms. She has 5 of 2 kilogram boxes. This is 10 kilogram of grass seed. 10 kilogram is larger than 9.3 recurring kilograms. So the conclusion is, yes, Maisie has enough grass seed to make the lawn. Part B. Maisie opens the 5 boxes of grass seed. She finds that 4 of the boxes contain 2 kilogram of grass seed. The other box contains 1 kilogram of grass seed. Does this affect whether Maisie has enough grass seed to make her lawn? Give a reason for your answer. 4 boxes times 2 kilograms is 8 kilograms. 1 box times 1 kilogram is 1 kilogram. Maisie has a total of 9 kilograms of grass seed, but she needs 9 1/3 kilograms. So the conclusion is, yes, this affects it. She doesn't have enough grass seed. Question 5. Amanda has 2 fair, free-sided spinners. Amanda spins each spinner once. Complete the probability tree diagram. Looking at spinner A, the probability that it lands on 2 is 1 out of 3 because there is only one side that is labeled as 2 out of the total of 3 sides, and the probability that does not land on 2 is 2 out of 3. Spinner B, the probability that it lands on 2 is 1/3, and the probability that does not land on 2 is 2 out of 3. Part B. Work out the probability that spinner A lands on 2 and spinner B does not land on 2. As we go along the branches, we times the probabilities. Looking at the branches, the probability that it lands on 2 is 1/3, times the probability that spinner B does not land on 2 is 2 out of 3. This results in 2 out of 9. Question 6. Use these graphs to solve the simultaneous equations. Looking at the 2 straight lines on the graph, it crosses at point where x is -2 and y is equal to 4. This is the solution. Part B. Use this graph to find estimates for the solution of the quadratic equation x squared minus 4x plus 2 equals 0. The quadratic graph that is drawn is y equals x squared minus 4x plus 2. Notice that in the question we have the same equation but the y is replaced by a 0. So we can find the solution to this by reading off the points on the graph where the y is equal to 0, as highlighted in yellow. X is 0.6 and 3.4. Question 7. There is a total of 45 boys and girls in a choir. The mean age of the 18 boys is 16.2 years. The mean age of the 27 girls is 16.7 years. Calculate the mean age of all 45 boys and girls. The mean age of the boys is the total ages of the boys summed up divided by the total number of boys. Replacing what is given, the mean age of the boys is 16.2. This is equal to total ages of the boys over 18, which is the total number of boys. Rearranging this, the total ages of boys is 16.2 times 18, and this is 291.6. Using the same calculation, the total ages of girls is 16.7, this is the mean, times 27, the total number of girls. This is equal to 450.9. Putting all of these together, the total ages of all boys and girls is 291.6, the total ages of boys, plus 450.9, the total ages of girls, divided by 45, the total number of boys and girls. And this is 16.5. Question 8. There are some counters in a bag. The counters are blue or green or red or yellow. The table shows the probabilities that a counter taken at random from the bag will be blue or will be green. The probability that a counter taken at random from the bag will be red is 5 times the probability that the counter will be yellow. There are 300 counters in the bag. Work out the number of yellow counters in the bag. If the probability of yellow is x, then the probability of red is 5 times x. All the probabilities add up to 1, so we can set up an equation. 0.32 plus 0.20 plus 5x plus x is equal to 1. 0.52 plus 6x is equal to 1. Subtracting 0.52 from both sides, we've got 6x is equal to 0.48, dividing by 6, x is equal to 0.08. It is given that there are 300 counters in the bag. To work out the number of yellow counters, we do 300 times the probability of yellow counters, 0.08. This is 24 yellow counters. Question 9. The diagram shows a prism. The cross-section of the prism has exactly one line of symmetry. Work out the volume of the prism. Give your answer correct to 3 significant figures. We can start by drawing in the line of symmetry. This is going to create some right angles here. It will also split the 10 cm line into 5s and 5s. If we draw out half of the triangle that is on the top, we can use trigonometry to work out the height and then work out the area. The side opposite to 40 degrees is the height, the opposite side. The side with length 5 next to the 40 degrees is called adjacent. Writing out SOHCAHTOA, we can tick how many O's we have, and we can tick how many A's we have. TOA has the most ticks, so we are using the formula tan theta equals opposite over adjacent. Replacing the values, we have tan 40 degrees is equal to h over 5, so the height is equal to 5 times tan 40. Typing this in the calculator, we have 4.195498 and so on. Make sure that you don't round too early, so you keep the accuracy of the final answer. To work out the area of the full triangle, the top part of the cross-section, we need the height, which we just calculated, and the base is 10 centimeters. So the area will be base times height divided by 2. 10 times 4.195498 divided by 2. And this is equal to 20.97749 and so on. The area of the rectangle, the bottom part of the cross-section, is base times height, which is 10 times 12 equals 120. And the area of the full cross-section is the sum of these two areas, 20.97749 plus 120, which is equal to 140.97749. Now we have all the information we need to work out the volume of the prism. The area of the cross-section times the length of the prism, and this is 140.97749 times 20 equals 2819.5498. We need to round to 3 significant figures, so the final answer is 2820. Question 10. A person's heart beats approximately 10 to the power of 5 times each day. A person lives approximately 81 years. Work out an estimate for the number of times a person's heart beats in their lifetime. Give your answer in standard form, correct to 2 significant figures. From the first sentence, we have 10 to the power of 5 beats per day. There are 365 days in a year, so we times this by 365. And the second sentence tells us that a person lives for approximately 81 years, so we times this by 81. This is equal to 2,956,500,000. Rounding it to 2 significant figures, this becomes 3 billion. Writing this in standard form is 3 times 10 to the power of 9, because there are 9 zeros after the 3. Part B. 2 times 10 to the power of 12 red blood cells have a total mass of 90 grams. Work out the average mass of one red blood cell. Give your answer in standard form. To work out the average mass of one red blood cell, we divide the total mass by the number of blood cells. That is, 90 divided by 2 times 10 to the power of 12 equals 4.5 times 10 to the power of minus 11. When you type this in the calculator, it should give you the answer in standard form straight away. Question 11. Triangle P is rotated 180 degrees about 0, 0 to give triangle Q. Triangle Q is translated by 5 minus 2 to give triangle R. Describe fully the single transformation that maps triangle P onto triangle R. Triangle P is rotated 180 degrees about 0, 0. When we are rotating 180 degrees, we are actually forming a trajectory of a straight line. The marked corner of the triangle, the coordinate point 1, 2, after it has been rotated, will be projected to the coordinate point minus 1, minus 2. After the rotation, the triangle will be upside down, which we can label triangle Q. The triangle Q is translated by the column vector 5 minus 2 to give triangle R. We can start the translation by picking one of the corners, moving it 5 steps in the x direction and minus 2 steps in the y direction. And from here we can complete the drawing of triangle R. And finally, we need to describe fully the single transformation that maps triangle P onto triangle R. Joining 2 pairs of corresponding corners with the ruler, we can find the center of rotation, but only when it has been rotated 180 degrees. And when we have a rotation over 180 degrees, this is also equivalent to an enlargement by a scale factor of -1, same center. So the center of rotation is 2.5 minus 1. The full description is rotation 180 degrees about 2.5 minus 1. Or another possible equivalent answer is it's an enlargement by scale factor -1, center 2.5 minus 1. Part B. Under the transformation that maps triangle P onto triangle R, the point A is invariant. Write down the coordinate of point A. Looking at the diagram, there is only one point that is invariant, and this is 2.5 minus 1. Question 12. Express x over x plus 2 plus 2x over x minus 4 as a single fraction in its simplest form. First step, we need to make sure that the two fractions have a common denominator. Timesing the denominator of the first fraction by x minus 4, we also have to times the top by x minus 4 to make sure that the fractions stay equivalent. Then timesing the second fraction by x plus 2. Now we can add the two fractions because they have the same denominator, x plus 2 times x minus 4. Multiplying out the brackets, x times x is x squared, x times minus 4 is minus 4x, 2x times x is plus 2x squared, 2x times 2 is plus 4x. And finally, simplifying the top will give us the final answer. X squared plus 2x squared is 3x squared, minus 4x plus 4x is 0, over x plus 2 times x minus 4. Part B. Expand and simplify the multiplication of these three brackets. Let's start by multiplying the first two brackets. X times 2x is 2x squared, x times 3 plus 3x, minus 3 times 2x minus 6x, minus 3 times 3 is minus 9. After adding the two middle terms, 3x minus 6x, this becomes 2x squared minus 3x minus 9. Now we have to multiply this result by the third bracket. 2x squared times 4x is 8x cubed, 2x squared times 5 is 10x squared, minus 3x times 4x is minus 12x squared, minus 3x times 5 is minus 15x, minus 9 times 4x is minus 36x, minus 9 times 5 is minus 45. Simplifying this further, we have 8x cubed minus 2x squared minus 51x minus 45. Question 13. On the grid, show by shading the region that satisfies all these inequalities. Label the region R. For the inequality x larger or equal to 0, we need to draw the line x equals to 0, and it's going to be a solid line because the 0 is also included. The inequality x larger or equal to 0 represents the whole region to the right of this line. For the second inequality, we need to draw the line x equals to 2. And the region to the left of this line represents all the points where the x is less than or equal to 2. For the third inequality, we need to draw in the line y equals x plus 3. We can start drawing the line from the y-intercept, which is 3, and has a gradient of 1. The region under this green line represents all the coordinate points where y is less than or equal to x plus 3. The last inequality looks a little bit more complex, but if we find two easy coordinate points, then we can draw the line that we are looking for. The simplest points that we can work with is when x or y is equal to 0. When x is equal to 0, replacing x in this inequality, the 2x will become 0, so the inequality will become 0 plus 3y larger or equal to 6. 3y is larger or equal to 6, and dividing across by 3, the y is larger or equal to 2. The coordinate point that we are looking for when x is equal to 0 is 0, 2. When y is equal to 0, we have 2x plus 0 is larger or equal to 6. Simplifying this, x is larger or equal to 3. So the coordinate point that we are looking for when y is equal to 0 is 3, 0. Plotting these 2 points on the graph, we can draw the line 2x plus 3y equals 6. The region above this line represents the inequality 2x plus 3y larger or equal to 6. We need to shade in the overlapping region and label it with R. Part B. The diagram below shows the region S that satisfies the inequalities that are listed. Jeffrey says that the point with coordinates 2, 4 does not satisfy all the inequalities because it does not lie on the shaded region. Is Jeffrey correct? You must give a reason for your answer. The coordinate point 2, 4 is on the line x plus y equals 6. In these type of questions, you need to know that when you have the symbols less than or equal to and larger or equal to, all points on the line are included. And when you have the symbols less than or larger than, the points on the line are not included. To answer the question, is Jeffrey correct? No, he's not correct. The point 2, 4 satisfies the inequality x plus y less than or equal to 6, because if you replace the values of x, 2, plus y being 4, it works out as 6, which fits the statement less than or equal to 6. Question 14. Points BDE and F lie on a circle. ABC is the tangent to the circle at B. Find the size of angle ABD. You must give a reason for each stage of your working. Looking at the cyclic quadrilateral, angle DBF is 180 minus 100 equals 80 degrees. Because opposite angles of a cyclic quadrilateral add up to 180 degrees. DBFE is a cyclic quadrilateral. Using the triangle BFD, we can work out the angle BFD. That is 180 minus 80 minus 40 equals 60 degrees. Because angles in a triangle add up to 180 degrees. The angles highlighted in yellow are equal to each other. So the angle ABD is 60 degrees because of the alternate segment theorem. Question 15. Prove algebraically that 0.73 recurring can be written as 11 over 15. Let x equal 0.73 recurring. Then, writing out the recurring part, this is the same as 0.7333 and so on. If we multiply both sides by 10, we have 10x is equal to 7.333 and so on. The reason we multiply this, so we have two equations that we can subtract from each other and eliminate the recurring part. Labeling the equations 1 and 2, equation 2 minus equation 1 will be 10x minus x, which is 9x, and 7.333 minus 0.7333 is 6.6. We times both sides by 10, so instead of the decimal 6.6, we have 66. Then divide by 90. At this point, you can just use a calculator if you want. 66 divided by 90. And press the SD button if you need to convert it to a fraction. That is 11 over 15. Question 16. Here is a speed time graph for a car. Work out an estimate for the distance the car traveled in the first 30 seconds. The distance represents the area under the graph. The area under the graph, shaded in yellow, represents the distance traveled in the first 30 seconds. It looks like a triangle, so we can use the area of a triangle to estimate the distance. The area of the triangle is base times height times half. 30 times 9 times half. This is 135. One way of thinking of the area unit of a speed time graph is by doing meter per second times second, and that is equal to meters. So the answer is 135 meters. Part B. Is your answer to Part A an underestimate or an overestimate of the actual distance the car traveled in the first 30 seconds? Give a reason for your answer. It is an underestimate because the area between the hypotenuse and the curve is not included. Part C. Julianne used the graph to answer this question. Work out an estimate for the acceleration of the car at time 60 seconds. Here is Julianne's working. Acceleration is equal to speed divided by time. Equals 13 divided by 60 equals 0.216 recurring meter per second squared. Julianne's method does not give a good estimate of the acceleration at time 60 seconds. Explain why. We can see that Julian just simply took the coordinate point 60, 13, but what he should have done is draw a tangent at that point and work out the gradient of that tangent. So the explanation is that it doesn't give a good estimate because to work out an estimate for the acceleration at 60 seconds, he needs to work out the gradient of the tangent. Question 17. The histogram gives information about the distances 80 competitors jumped in a long jump competition. Calculate an estimate for the mean distance. The x-axis shows us the distance. The y-axis shows us the frequency density. To work out the frequency, we do frequency density times distance. The area of the rectangles gives us the frequency of each of these sections. The frequency of the first section is 10 times 7.2 minus 6.4. This is 8, where the 10 represents the frequency density and 7.2 is the upper bound and 6.4 is the lower bound of this section. This means that there were 8 people in the long jump competition whose result was between 7.2 and 6.4 meters. The second frequency is 50 times 7.6 minus 7.2, this is 20, and the third one is 100 times 8 minus 7.6 is 40, and the fourth frequency is 60 times 8.2 minus 8 equals 12. We know that we calculated this correctly because their sum equals to 80, which was already given. There are 80 competitors. To calculate the estimate for the mean, we need the sum of frequency times midpoint for each of the sections. That is 8 times 6.8, the midpoint of the first section, plus 20 times 7.4, the midpoint of the second section, plus 40 times 7.8, plus 12 times 8.1, divide by 80, the total frequency, and this is equal to 7.645. Question 18. The diagram shows a cube. AH is 11.3 centimeters, correct to the nearest millimeter. Calculate the lower bound for the length of an edge of the cube. You must show all your working. The formula for the length of a diagonal is the square root of length squared plus width squared plus height squared. Let's label the edges as x. The lower bound of the diagonal AH is 11.25 centimeters. Replacing the values in the formula, we have 11.25 equals square root of x squared plus x squared plus x squared. Simplifying this, 11.25 is x square root of 3. Dividing across by square root of 3, we have our final answer. X is equal to 6.495190,528. Question 19. ABCDEF is a regular hexagon with side length x. This hexagon is enlarged, center F, by a scale factor p to give hexagon FGHIJK. Show that the area of the shaded region in the diagram is given by 3 square root of 3 over 2, bracket open, p squared minus 1, bracket closed, x squared. Because this is a regular hexagon, the triangle labeled A, that is formed by BC and the center of the hexagon, is an equilateral triangle. So the area of this triangle is half times x squared sine 60, using the formula half AB sine C. Sine 60 is square root of 3 over 2, so this simplifies to square root of 3 over 4 x squared. The area of the small hexagon is 6 times the area of the triangle that we have just calculated. This is 3 square root of 3 over 2 x squared. Following on from this, we can also write down the area of the large hexagon, simply by replacing the x by px, the side of the large hexagon. This simplifies to 3 square root of 3 over 2 p squared x squared. The area of the shaded region is the area of the large hexagon minus the area of the small hexagon. Factorizing 3 square root of 3 over 2 and x squared will give us 3 square root of 3 over 2 x squared p squared minus 1. And moving the x squared behind the bracket will be the same thing. So the final answer is 3 square root of 3 over 2, bracket open, p squared minus 1, bracket closed, x squared. Question 20. Here is a list of 5 numbers. Find the lowest common multiple of these 5 numbers. Because the base 98 is the same for all of these numbers, the lowest common multiple will be the number with the highest power, that is 98 to the power of 91. Question 21. 5c plus d equals c plus 4d. Find the ratio c to d. Let's start by moving all the c's to one side and all the d's to the other side. Subtracting c from both sides will result in 4c plus d equals 4d. Subtracting d becomes 4c equals 3d. Therefore, the ratio c to d is 3 to 4. Part B. 6x squared equals 7xy plus 20y squared, where x and y are larger than 0. Find the ratio x to y. First, let's move everything to one side. 6x squared minus 7xy minus 20y squared is equal to 0. Dividing across by y squared becomes 6x squared over y squared minus 7x over y minus 20 equals 0. Now that we have divided across by y squared, if you replace x over y with another letter, this equation becomes a much more familiar quadratic equation. Let a equals x over y. Then we have 6a squared minus 7a minus 20 equals 0. Now we can solve it as a quadratic equation. If you want, go ahead and solve it with a quadratic formula. I'm going to demonstrate this with the factorization method. To get started, we need to multiply the coefficient of the first term by the coefficient of the last term. 6 times minus 20. This is minus 120. And we need to find the factor pair of minus 120 that adds up to minus 7. This is 8 plus minus 15. Now we rewrite the minus 7a as 8a minus 15a. Then we factorize the first two terms and the last two terms separately. 6a squared plus 8a becomes 2a bracket open 3a plus 4, and minus 15a minus 20 becomes minus 5 bracket open 3a plus 4 bracket closed. We know that we are on the right track because the brackets are the same. To factorize this fully, we write them in double brackets, 3a plus 4 and 2a minus 5. If you make the first bracket equal to 0, then the a becomes minus 4 over 3. And when we make the second bracket equal to 0, the a becomes 5 over 2. The x and y are positive numbers, so the first solution, minus 4 over 3, is not a solution that qualifies. But the second solution, a equals 5 over 2, is what we are looking for. This is equal to x over y. Rewriting this as a ratio, x to y is 5 to 2.